Empty set is a set that has no elements, and it is represented by the symbol, by this symbol or a curly bracket with no elements inside. Example, the set of negative numbers between 6 and 20. So definitely, there will be no negative numbers between positive 6 and positive 20. So the answer here is an empty set or a null set. When you say singleton set, it is a set that contains only one element. For example, set B is a set of all x such that x is more than 3 but less than 5, where x is a whole number. So we can only think of one whole number between 3 and 5, and that is 4. There is no other than 4. It has only one element that this set contains. Therefore, this set is called a singleton set because it contains only one element. When you say finite set, it is a set in which number of elements are limited and can be counted. Example, set C is a set containing 2, 4, 6. So since we can count the number of elements, in this case, the cardinality is 3, therefore, this set is called a finite set. When you say infinite set, it is a set in which number of elements are unlimited and cannot be counted. Example, set C is a set containing 0, 2, 4, 6, and so on and so forth. Notice that there is an ellipsis here, which tells us that it keeps on going forever. So it means the cardinality is infinite. So it means it cannot be, we can't have an exact amount or exact number of cardinality. Therefore, set C is considered as an infinite set. When you say universal set, it is a set which contains all the elements of the other given sets. It is usually represented by the symbol U. So we have a given 3 sets here. Set A is a set containing 1, 3, 5. Set B is a set containing 2, 4, 6. Set C is a set containing 2, 3, 5, 7. If all the elements of these 3 sets are listed in one set, so let's say set U is a set containing 1, 2, 3, 4, 5, 6, 7. This set U is considered as a universal set because all the elements of these 3 sets can be found in this set, which is called the universal set. When you say power set, it is the set of all subsets of a given set. And the power set of A, for example, is denoted by the notation power set of A is equal to all x such that x is an element or is a subset of A. So for example, we have a given set A is a set containing 2, 4, 6. So first, we're going to identify all its subsets. And the subsets are 2, 4, this one, 6, 2, 4, 2, 6, 4, 6, 2, 4, 6, and the empty set. Since we know that empty set is a subset of all sets. So these are all the lists of the subsets if a set has 3 elements. And these subsets are actually the power set of this given set. We have 4 pairs of sets. And these are, one of it is the equal sets. Equal sets are sets that contains the same elements. For example, set A is a set containing 2, 4, 6. Set B is a set of all x such that x is more than 1 but less than 7, wherein x is an even number. So, if we're going to write the elements in set B, so when you say even number, so these are numbers ends in 0, 2, 4, 6, 8. Now, these even numbers are located between 1 and 7. So these numbers are 2, 4, 6. 8 is more than 7, so it is not included here. Notice that they have the same elements. Therefore, we can say that set A and set B are equal sets because they have the same elements and the same cardinality. While equivalent sets are sets that contain the same number of elements. So let's say we have a given set C here, which is a set containing 1, 3, 5, and set D contains an elements A, B, C. So they don't have the same elements, but they have the same cardinality. The cardinality of set C is 3. The cardinality of set D is also 3. Therefore, these two sets are said to be equivalent sets. Disjoint sets are sets that do not have a common elements. So let's say we have a given set A is a set containing 2, 4, 6, and set B is a set containing 1, 3, 5. Using a Venn diagram, we can see visually that let's say set A is a set containing 2, 4, 6, and set B has an element containing 1, 3, 5. We can see visually that there is no common between two sets. Therefore, these two sets are said to be disjoint sets. And when we say overlapping sets, these are sets that contains a common elements. So let's say we have a set C, which is a set containing 3, 5, 7, and set D is a set containing 1, 2, 3, 4, 5. Using a Venn diagram, let's say this is our set A, which contains 3, 5, 7. And this is our set D, which contains 1, 2, 3, 4, 5. Notice that 3 and 5 is common to set C and set D. Therefore, the two sets are said to be overlapping sets.